everybody, this is Andrew Phillips here with another computer science tutorial. Oh, excuse me, be loud for a second. Sorry, I wanted to move that farther away from my leg. So, last tutorial, I didn't know so much about it, but this I definitely know about. This I actually did in computer class, and this is fairly simple. A few complicated things, but other than that, fairly simple. So let's get it started. So it's a graph theory. So what is graph theory? Well, a graph is a collection of nodes that are somewhat connected. They are connected by nodes and edges. Notice not all graphs are connected. I'll explain what I mean by connected graphs. You'll see what I mean by graphs. So it works a lot like NFAs and finite state machines. You have a node, two nodes connected by an edge. This is an edge. So they connect these two. So you can send information from node A to node B. So what is a node? This is a node. Now we have the basics of graph theory. Yeah, okay, so now we have the absolute basics of what graph theory is. We can move on to a little more complicated stuff. So a node is a point on a graph. Okay. Let's look at some connected graphs. So we know the basics of, so now we know the basics of graph theory. Let us go a little further. A connected graph has all the nodes connected by edges. So you can see that it's all connected. If we had a node here that's not connected, that's an unconnected graph. All right, let's look at the graph below. We did that, and I just explained why. Unconnected graph. It's the same idea, except it's not connected by edges. We can see all of this, and then this is alone, not connected to anything. What I should have next is cyclic, but I'm going to go to that just before depth first and breadth first searches. I will mention Dijkstra's algorithm, but I'm going to reserve Dijkstra's algorithm for another tutorial. Probably just a side tutorial later on for a continuation of graph theory, Dijkstra's algorithm. And technically I should leave out breadth first, depth first searches because those are a little more complicated, but I'll get back to that. Weighted graphs. You use this for Dijkstra's algorithm. It's when you have a weight on the edge. So a weighted graph is a graph that has numbers on the edge that determine the weight of the edge. So if you had like 1 here, 9 would be greater than 1. And we'll go into that when we do Dijkstra's algorithm next tutorial, or whenever tutorial that is. Bipartite graphs. So this can be a little confusing to grasp, but it's even more confusing to program. Well, not really. It's just a little more different to program. So the big thing we know is we have 2 poles, right? And every other node goes to 1 pole. So we have A, B, C, D, E, F. It cannot go A, B, C, D, E. It has to go every other. That's the part of a bipartite graph. Now we get to cyclic graphs, which is quite simple to grasp. A cyclic graph is a graph that completes a cycle. Assume the following graph. We have this, and we can see everything completes a cycle. We can have another edge going here. We have 2 cyclic graphs. So when your programming is cyclic, you just look for they all connect by a graph. All right, let's get into breadth first searches. So I'm going to need to use my Drawy tool. If I know where that is. If you go here, scribble. So the first thing we know about a breadth first search is that it uses a queue. We should know what a queue is, and if you don't, I'm going to go to my YouTube channel, look up Squeever on YouTube, and then look for stacks and queues, and you'll understand what I'm talking about. So let's create a queue. Yeah, I don't like that color. Let's make it a different color. Oh, crud. Yeah, how do I change the color here? Okay, well, apparently we just have this. So it's hard to see, though. It's annoying. Yeah, that's really annoying. Why is it doing that? Edit. You can't do it. Okay, well then I guess we're just stuck with this material. So hopefully you can see. So we have a queue here. This is our queue. And we're going to start off with our visited nodes. So that will be A. And we're going to put A in here. Ugh, you really can't see it. Fine, have your way. So we're just going to do it with shapes. So we have our queue. And we know we have node A. Or actually, we know we have node A. Alright, So we can add A to our queue. So we add A to our queue. Now we look at all our, and then we add A to our set of finished edges, A, and then we go to all the other visited nodes. Oh, this is annoying. Sorry, guys. I wish I had a better tool for editing, but I don't. This is extremely aggravating. Cannot even express. Oh my goodness, this is really, ugh. Okay, so we add B to our queue and C to our queue. And we can go here and we can add B and C. And then what we can do is we can DQ A, and we know everything there is visited. Okay, so the big thing here is that A is the first visited node, the initial node, so that goes into our queue and our list. Then we look at all the other nodes in alphabetical order, B and C, or numerical order, whatever you're doing. And you'll see numerical order in just a second. So we look at B and C, we're going to add those to our list of visited nodes, add it to our queue. And then we're going to look at all the things. All right, so then we NQ A, and DQ A, and then we DQ B, and then we look at everything B is connected to. So that's just going to be E. So we add E to our set. All right, now that's visited. So now we look at everything C is connected to, which would be D. And we DQ C. And then we add D to our set. All right, so now we have a list of visited nodes. Remember, we can't go past visited nodes twice. So then we're going to NQ E. Well, there are no unvisited nodes there, and we NQ D, or DQ, I'm sorry, I keep saying NQ, we DQ D. And we see nothing because they're all visited. And then that is our breadth first search. That is how you do it. How am I doing for time? 7 minutes, okay. Sorry about that. So now let's go on to depth first search. So we have this graph here. So let's start off by making our stack. This is the thing now. We're using a stack. Whoops. So it's a little different. It's just a tad different. So let's add in a stack. Okay. And then let's add in what we're going to use as something we can write on. Okay. So the first thing we need to know is that our first visited node is going to be 1. We're going to put that on our stack. And then we look at all the other visited nodes, 2 and 3. 2 and 3. So we add 1, 2, and 3 to our set. Not 22, 3. Not 23, 3. Okay, and then we're going to go to our stack, and we're going to pop off the first visited node. So now we have 3, and we look at all the unvisited nodes. Well, these are all visited, so we add in 5. We add that to our list of visited nodes. Now we can pop off 5 from the stack, and we look at all the unvisited nodes, which would be 4. All right, and then we go back and we pop off everything off of our stack. So we see 2 already visited and 1 already visited. There we go. Now what we have is a empty stack, which is what we were looking for. You're not done with the search until your stack is empty. And then we have here our list of visited nodes. So a quick recap. An edge is the thing connecting a node. A node is the point on a graph. Connected graphs have connections throughout all the nodes. Connected is unconnected, doesn't have everything connected. A directed graph, which usually uses for Dijkstra's algorithm, or not Dijkstra's algorithm. We didn't do anything with directed graphs, but when you're doing traversals with directed graphs, it's a little different, and I'll go into that in the tutorial when I'm doing Dijkstra's algorithm. That'll be a little more heavy in concept. This is just very simple. Okay, let me look at weighted graphs. Just has a weight on the edge. Bipartite graphs, 2 poles. Cyclic graphs, all arranged in a cycle. And breadth first and depth first searches, where you have a queue and you go through every visited node, and you have a stack, you go through every visited node. Okay, guys, thank you for watching. That is all for today, and please +1 this is going to be on Google+, retweet it, like it if it's on Twitter, and if it's on my website, just do whatever you please. Alright, everybody, thank you all for watching, and goodbye.